Okay, so moving on in our videos, before we actually code the apple, because the apple is something that moves in a diagonal direction and is sometimes actually it will obviously hit one of the corners of the screen, we actually need to code the screen borders, right? We need to define where are the places that when the apple hits those corners, it will change its direction. It's basically reflect its direction. Okay, so this is not an issue for this lecture, but I just need to expose why we need to do this first before we code the actual movement of the apple. I'd also like to apologize for my voice. I catch a cold, so it's a little bit different, which is of course not an issue for our series. So let's continue. Also, one more comment before we move on. Don't forget to save your scene. Just click File, Save Scene. It will pop up a little window that's gonna ask you for a place to save it inside the assets folder and a name for your scene. As you can see, I've already saved mine. Is this game scene here? It has this Unity icon, so this is a scene, and you just double click it and it's gonna open the scene for you. So after every single lecture we do, I'll ask you to save the scene. When I don't, do it anyways because I might forget. So what were we gonna use to define the borders of our game? I'm gonna create a new empty game object, going to game object, create empty, and I'm gonna name this object screen collider. And to this game object, I'm going to add a component, which is actually a collider, but it's a specific type of collider that we didn't see yet. We're going to go to component, physics 2D, and we're going to choose one of these four colliders, and we're going to go for the edge collider. And what does the edge collider do? If you pay attention, it has this green line here, and this is an edge of the collision. So every time one of the 2D colliders that we have in our scene hit this edge here, it's gonna collide with it. So this is basically something that we can define, and to edit this collider that's gonna wrap our scene, we can just click on this icon here, and we can click on one of these corners and we can pull it. If you want to add another point, you just click at any place here and drag it out or drag it in. Now you have 3 points. Just drag another one so we can wrap our scenario. But as you can see, it's very hard to encapsulate our screen with this, especially when our screen changes its size. As you can see, we have an aspect for our game, and this varies according to the device where you're playing the game. So if you're playing on an iPad, of course the dimensions of the screen are going to be different, therefore the aspect ratio will be different. The same applies for an iPhone or maybe an Android device or maybe any computer that you might have. So if you choose a different aspect ratio, for instance this one, it'll have another appearance, or this one. So you can see that the aspect ratio changes the dimensions, and of course this collider we've just defined is not going to apply for every dimension that we might have, so we need to create it dynamically. You can check this option gizmos here, so it's going to show where the actual collider is on the screen. It's kind of hard to see, but there's a green line here that is going to actually show where the collider is. So if I move this point here, it's gonna move that edge on the screen. It's just a way that we can see the gizmos. This is a gizmo. This is something that is drawn, but it's not supposed to be presented on the game view. But if we choose this option, gizmos, we're gonna allow this thing to be rendered on the game scene, basically for debugging. So doing this, we can see that the collider gets shown here on the game view. So what are we going to do? In this edge collider component, you see that there's an points thing that you can expand here. And this is basically the set of points that are going to make this edge collider. So for each 2 points you get an edge. So this is 1, this is 1. So for these 2 you get an edge. For this one and this one you get another edge. For this one and this one you get another edge. And for this one and this one you get another edge. So as you can see, there are 5 points to represent 4 edges. And what we basically have to do, we need to assign these points dynamically through scripting. So what we need to do is to check where the corners of the screen are in world coordinates, which is these coordinates that are represented in the scene. So here I have a little draw that shows me the world view and the screen view. The world view is something that is 3D, and the screen view is something that is 2D. It's basically the pixels of our screen. So let's say that our screen starts in this bottom corner here, and this is the pixel 0, 0. And it goes all the way up to this one, which is the pixel, let's say that is 1280 by 720. This is HD, okay? We have 1280 width and 720 height, okay? So what we want to do is basically to get all of these 4 corners. What will this one be? So as you can see, the width for this point is 0 because we didn't move along the x-axis, so it's 0, but the height is 720. In this case, the width is 1280 because we move all the way to the end of the x-axis, but the height is 0 because we didn't move along the y-axis. So what we need to do is basically we need to grab those pixels, we need to grab these things that are in screen view, in screen coordinates, and we need to get their correspondent position in 3D. So we need to basically do this conversion from screen view to world view. So let's say that we have a ball here, that's a 3D thing, and let's say that this ball's position is in the world coordinates is 0 in x, 20 in the y-axis, and 3.4 on the z-axis. When the game renders this ball into the screen view, it gets, let's say, it gets placed here. So this is the ball, it's actually in 2D, and the screen coordinates for this are going to be, let's say, 1000 by 680. So as you can see, when I converted this thing that is in world view to the screen view, it gets this position here. But if I do the opposite, if I convert this position, which is 1780, to the 3D view, to the world view, it's gonna get this position here. So I want to do this same thing, but instead of doing it for an object or anything like that, I want to do it fixed coordinates, which are the four corners of my screen. So I'm basically gonna connect this corner, so this is gonna form an edge. I'm gonna connect these 2 corners, I'm gonna connect these 2, and I'm gonna connect these 2, and they're gonna form our collider. But how do we actually go on and code this? It's very simple. First of all, I'm gonna create a new script, and I'm gonna name it Collider Creator. Double click to open it up. So one thing that we must know is that all these transformations that go from 2D to 3D, from screen view to world view, they are done through the camera component. So we need to have a reference for the camera. So let's put a public camera reference to a camera, of course, camera component, and let's type in cam. We basically have a reference for the camera, and it's called cam. It's a variable that's in our script. And we also need a reference for the edge collider because we want to edit its points. So we can define public edge collider 2D, and this is my collider. Okay, so when we convert from 2D to 3D, we're gonna get a vector 3, which is basically a point in space. We're basically gonna call a function that will convert a point from the screen to a point in the world, and as said, this is gonna return a point in space, which is a vector 3. So I'm gonna assign whatever my function returns to a vector 3 type. And I'm gonna start by getting the bottom left corner. So this is the bottom left. And the bottom left is the pixel 0, 0. So I'm going to convert the pixel 0, 0 from my screen to the world. And I do this by saying cam. We're going to access a function of the camera component, which is called screen to world point. And it makes sense, right? I want to convert a point from screen to world. And what is this point in screen? We need to pass a vector 3. And it's 0, 0. This is for x and y. And let's say that the z is worth 0, even though it's not going to be used because we're not dealing with depth here. This is all 2D, so we can easily pass in z as being 0. So we're going to convert a pixel 0, 0 into the world coordinates. We can do the same for, let's say, the upper left. And this is basically just changing the height instead of being 0 to whatever height is our screen view. And how do I dynamically get the height of the game view? I do this by saying, of course, x is going to be 0 because we're dealing with the left corners. So the y is going to be screen.height. And this is going to tell me what the height is for this specific aspect ratio. This is always going to be the height of the resolution that I pick for my game. Now we can move on to the upper right. So the upper right corner is the corner that has x being evaluated at its maximum and the height as well. So we need to pass in the maximum x value for our screen coordinates. So as we did with the height, we can easily do it width. So screen.width, this is our x value. The height keeps being screen.height, and z is worth 0. So now for the last point, this is the bottom right. We don't have any height, so y is going to be 0. But we are at the right of the screen, so x needs to be screen.width. There you go. Now we just need to attach these positions as being the points of the collider. And we can do that by doing collider.points. Make sure you grab your variable and not a component that has a capitalized C. So collider.points. And we need to say that this is going to be a new set of points. So we do new vector2 of 5 elements. As you saw before, we need 5 elements to create 4 edges. And to define what these points are going to be, we need to put curly brackets, and inside here we're going to pass in the 5 elements that's going to compose our vector of points. Note that this is an array of vector 2, but it shouldn't be a problem because there's an implicit conversion between vector 3 and vector 2. So let's pass in our 5 points. Let's start by the bottom left. Now we can go to the upper left, now upper right, and now bottom right. We're doing this in a clockwise direction. And now to finish, we need to pass the first point again as being the last one. So we're gonna wrap our screen with this collider. And this should do it. So let's go back to Unity. Let's attach our collider creator into our screen collider game object. Now we need a reference for the camera. So let's drag our main camera here. And let's also drag the edge collider 2D as being our collider. And when I press play, hopefully we will have something that wraps our game, but not quite. So something happened here. And as you can see, our screen collider has a Y position of -4.6. And this can't happen because, as you can see, when I move the collider and it has its points defined, the points are actually going to be summed up to the actual position of this collider, so it will displace the points. And what we need to do to solve this is basically we need to reset this position. So click on this little gear here, reset, and when I hit play, there you go. It looks like now we have our screen wrapped up with this collider. Okay, and to check if this is working, you can just maybe apply a rigid body to this apple. So let's apply a rigid body here. Component, physics 2D, rigid body 2D. And we can also apply a box collider to it so it's not going to fall through. Box collider. And when I hit play, there you go. It doesn't fall through our snare because it has this collider. And it works perfectly. So I'm going to keep these components in the apple. I'm just going to disable the gravity scale so gravity won't affect this element, and I'm gonna quickly save my scene, and this is it for this video.